Hi, Victor Morganti here from FactEngine. We're going to have a closer look at FactEngine itself, as FactEngine sits over the top of models created in the Boston conceptual modeling software. So we're sitting in front of Boston, and Boston is conceptual modeling software for polymodel databases. In fact, Boston treats any database as if it was a polymodel database. FactEngine is a layer that sits over the top of models created in Boston and is the namesake of FactEngine the business, and can be used as a business rule API or for natural language queries over your data lake or your databases, etc. So let's have a look at models created in Boston first, and then we'll dive into FactEngine and focus on the query language side of things. So we've got a model open in the Model Explorer. It's called the Cinema Bookings model, and some attribution. This model derives from one shared by Data Constellation on their page on GitHub, and we've got various pages in the model. So pages break down the model into sections so that it's easy to manage. If we look at a property graph schema view of this model, we can see that the model is for booking seats at a cinema. So imagine we're this couple and we want to book these seats to watch a film at a cinema. We can use say an application built over this database where a person made a booking for a session to watch a film at a cinema, and the booking is for one or more seats, and where a seat is in a row in a cinema and a seat is in a section. So this is a property graph schema view, and this looks like a traditional property graph that you might draw for, say, a Neo4j database, where we've got labels for edge types in capitals. We've got node types, and if we control click we can see the properties of each node type. So that's our property graph schema view. In Boston we know that we can also look at the same schema as an entity relationship diagram, and where a person made a booking for a session to watch a film at a cinema, and a booking has one or more seats through this many-to-many table, and a seat is in a row in a cinema, and a seat is in a section. Of course, we know in Boston we can morph between the different views, and we're looking at the same schema as either a property graph schema or an entity relationship diagram. The secret sauce of FactEngine and Boston is that we can also view the model as a object role model, and where the predicates for both the property graph schema view and the entity relationship diagram view are captured as predicates in the object role model view. We can see the same model elements: person, booking, session, film, cinema, row, seat and section, and linking them is what is known as fact types. If I click on a fact type, I can see its various readings, and where we might say seat is for booking, booking is for seat, or a booking has a seat, or a seat has a booking. And they're color coded here, where the model elements are green and the predicate is in purple there. So those predicates migrate to the entity relationship diagram view, where we can see that there are predicates on our foreign key relationships. So for instance, a booking is for a session, and a session has a booking. If I click on that, I can see the same object role modeling predicates, and add more of those if I need variations on the same relationship. Those same predicates migrate to our property graph schema view, and where we say booking is for a person, that's true, but if I click on booking is for person, I can see that it has the predicates person made booking and booking is for person. So that's a forward reading and a reciprocal reading. And I'm sharing this with you because when we have all those natural language predicates, we can use that for doing controlled natural language queries using FactEngine. So FactEngine sits over the top of models that sit over the top of databases to allow us to do apply business rules or query a database in controlled natural language or natural language. So I right clicked on the model and I'm going to open FactEngine, and I'll briefly describe the FactEngine. I'll just close these to give us more room. The FactEngine form as it is inside Boston. So at the top we've got a natural language text box where we can write queries in natural language. This dark text box here allows us to write controlled natural language FactEngine Query Language, or FEQL. And then we have a results view, the query that's generated for us for our database, and a graph visualization for our results if there is one. Now this particular database is over a SQLite database, and that's the SQLite logo. If I right click on the model and go to model configuration, I can see that it's set up as an SQLite database, and that's where the SQLite database sits on my hard drive on my computer. So let's write firstly a query in FactEngine Query Language, which typically starts with the word which. There are variations of this, but I'll show you the primary way of querying with FactEngine Query Language. So starting with which, I'm going to say which person, and you can see I can select predicates and model elements from this IntelliSense-like drop-down view, and we're going to say made a booking. There's hotkeys, so I can hit the A key for A, so made a booking. That, and I'm going to say is for a session, and then I'm going to say that is to watch. Now I'm going to hit N for node, and this is how you set up a node selection inside FEQL. So I've got in brackets film colon and then open quotes. So I'm going to say the Rocky, and you can see that's enclosed in brackets as if I was talking about a node type film. So the query reads, which person made a booking that is for a session to watch the film Rocky? I'm going to hit go on that, and we can see that Peter made a booking to watch the film Rocky, and these are the details of the booking that he made. The query in this instance is in SQL. If it was over a Neo4j database, this would be Cipher. If it was a TypeQL database, this would be TypeQL. I can write the same query in natural language, and I'll write a variation on it. So we know it was Peter, so I might say, which film did Peter make a booking for? Now that's going to get farmed out to a large language model, be converted to controlled natural language. So which film has a session that has a booking that is for the person Peter, and we can see that Peter made bookings for Rocky, Grease and Dr. Zhivago, and these are details of those bookings. Now if I want to say at which cinema, I might say booking for at which cinema and which seat, letter and row number. Let's see how that's returned. Right, so Peter made a booking at the Great Western Cinema, and it's for, because I know this database, I know that's in row 1, letter A. but I can put return clauses on here. So I can say return, and I'm going to say cinema. I should be able to just say cinema, seat, letter, and seat, letter, and seat row number, and hit go on that. And there we go, we've got Great Western Cinema, letter A, and row 1, and we could get the date, time, etc. as well. We can ask queries that do counts and group bys. So if I say how many seats are in the deluxe section of the Great Western Cinema, let's see how that goes. And we can see we've got 30 seats in the deluxe section in the Great Western Cinema. Here's our query, and we might even have a graph view on that. We don't have a graph view on that. Now, because we have a property graph schema view over what is a relational database in the classical sense, we can do very interesting things in beta fashion inside Boston and FactEngine. I'm just going to change that label momentarily to has, so that we can see that this is your typical property graph schema. And I'm going to grab a Cipher query, or open Cipher query, and inside FactEngine go to the query, rub out what's there, put in a open Cipher query. So match person is for a booking, so which person has a booking. That's for a seat that's in a row in a cinema, and where the booking is for a session, that is for a film, and the login name is Peter. So basically we want to know the details of bookings made by Peter to watch a film. So I'm going to change this to, I'm just going to put Cipher, but it is open Cipher, and hit go on that, and here's our results. So Peter at the Great Western Cinema made a booking to watch Rocky on this date. Now that query has been converted to SQL, and this is the laborious SQL for that query, but it was originally a open Cipher query. So we've modified a open source open Cipher to SQL query generator to operate over any database, and it's quite an interesting set of events where we haven't got any special type of database, relational database for our query. We've got a stock standard relational database, in this case here, that has a primary key over 1, 2, 3, 4, 5, 6, 7 columns, and where most of the tables in this database have a primary key of 2 or more columns. So booking has 1, 2, 3, 4 columns in its primary key, and yet we can convert open Cipher to SQL successfully to get our results. So that's a brief overview of the FactEngine form inside Boston. Now, so FactEngine is a business intelligence tool to do controlled natural language queries or natural language queries that will convert the query to the database query language type of the database that you're sitting over to get your results, and in some instances a graph a graph visualization of the results as well. So thank you very much for watching. I hope you enjoyed the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.